This is Dr. D. Govardhan, Professor Emeritus, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, we are discussing the effect of friction in connected bodies. In this content, the bodies may be consist of two or several. They are connected together by rope. These bodies may be lies in the same inclined plane, or maybe in horizontal, or it may be different inclined planes. The normal reactions plays a key role to determine the friction force which exists between the bodies and the surfaces on which it rests. For giving this explanation, I am taking one small problem here. A cord connects two bodies W and W2 are placed on an inclined plane, and cord is parallel to inclined plane as shown in figure. The coefficient of friction for W1 assume mu1 is given 0.15 and mu2 0.4. Determine the inclination of the plane to the horizontal and the tension in the cord when the motion is about to take place down the plane. This is the problem is given now. Since the body is moving down the plane, the friction force is always experienced between the contact bodies and surfaces in the opposite directions in which the body tends to slide. Since the body is moving downward directions, for the first body, the normal reactions is always perpendicular to the plane. Friction force is in opposite direction in which the body tends to slide. Since it is the body number 1, I am taking this N1 and the friction force is F1. Similarly, for the second body, it is also moving in downward directions. The normal reaction is perpendicular to the plane, assume it is N2, and the friction force is F2 acting in opposite directions. With respect to the body 1, the tension in the rope is always acts away from the object. It is represented as T. For the body 1, when we are drawing the feedback diagram, it acts toward the right side as shown in figure. And the weight, since it is always at in vertically downward directions, this force, it can be resolved into two components. One is the vertical and one more is the horizontal along the plane. Here, this angle now becomes alpha. The component of force, this is treated as W1 cos alpha, which is always balance the normal reactions. And this component of forces is called W1 sin alpha. It is acting in downward directions along the plane. This force is also called sliding force, which help the body to move in downward directions. Similarly, for the second body, the weight is perpendicular to the ground, and this force is also resolved in two components, perpendicular plane and inclined plane. This perpendicular plane it is treated as W2 cos alpha, the alpha, and horizontal component W2 sin alpha. Okay, in this case, we have to analyze the forces by taking the body W1 and W2 separately. Before analyzing the forces, we have to consider what are the values of N1 and N2 in terms of W. Here N1 is equal to, that is the normal reactions at the contact surface of the body 1. N1 is equal to W1 cos alpha. Hence, frictional force F1 is equal to mu N1, which is also equal to mu into W1 and cos alpha. Since the body is in equilibrium position and the forces are concurrent, hence we have to consider only two equilibrium equations, such as sigma Fx is equal to 0, that is the sum of the component of forces which are acting along the plane should be equal to 0, and the sum of the vertical forces which are acting perpendicular to the plane also equal to 0. So, by using the sum of the vertical forces which are acting along the perpendicular to the plane, that is used already to determine the normal reactions at the point of contact. And the second one is and resolve the forces along the plane and equating to 0, since it is in equilibrium conditions. The equation 1 becomes for the body 1, it is equal to, here T is assume the forces which are acting toward the right side are treated as positive and down negative. Then it becomes for the first body T positive, frictional force positive, and minus of W1 cos alpha, it should be equal to 0. From this relations, you can take it as T is equal to W1 cos alpha minus T. This is the equation number 1. Sorry, W1 minus F1. Similarly, for the second body, since the tension is acting in downward directions, because the tension in the cord is always acts away from the body, hence minus T minus W2 cos alpha, which should be equal to F2 now. By using the relations, we got again T is equal to F2 minus of F2 and minus of W2 cos alpha. Okay, it should be equal to sum of the forces which are acting along the plane is equal to 0. The forces which are acting toward the right side treated as positive. By using the relations, we got F2 minus of W2 cos alpha is equal to T is equal to minus F2, sorry, T is equal to plus F2 minus of W2 cos alpha. By using these equations here 2 and 1, we can determine the values of alpha as well as the T also. Okay, this is the method we have to follow for the connected bodies. When the two bodies are rest on inclined plane and connected with the cord as shown in figure. Okay, summary of this one once again. When the two bodies are connected together by using the cord and kept on an inclined plane, when the body is about to slide in downward directions, In order to analyze the forces, take the two bodies separately. For the first bodies, the tension is acting upward direction. For the second body, the tension is downward directions. Since the forces are acting on it are concurrent, hence two forces are only applicable for equilibrium position. Sigma fx is equal to 0, sigma fi is equal to 0. By using these two equations, we can determine the tension as well as the inclination of the plane. Determine the least value of force P to cause the motion to impede rightwards. Assume the coefficient of friction under the blocks to be 0.2 and the pulleys to be frictionless. Here, in this problem, assume just we have to determine the value of P, which is minimum values that is required to impede the motion of the connected bodies toward the right side. Okay, for this system, here we have taken the weight of the bodies, assume W1, it is equal to 150 newtons, and second one W2, assume just 100 newtons is given. The inclined plane, we are taking 60 degrees. Since the body is about to move toward the right side, the frictional force is always acts in opposite direction in which the body tends to slide. That means toward the right side. When we are drawing the free body diagrams for the W1 and W2, for W1, here for 150 newtons, this is called normal reactions, assume N1, and the frictional force is acting in downward direction, so F1. The weight is also there now, which is always acts perpendicular to the ground plane. It can be resolved into two components, the perpendicular as well as the horizontal to the plane. This horizontal plane always tends the body to move toward the downward directions, but the tension in the rope, which is acting away from the object, assume that T, according to this problem, it is moving toward the tension is acting toward the right side. Since the tension in the rope is same because it is connected over the frictionless pulley, hence for the second bodies, it is a normal reactions N2. The bodies tends to move toward the right side. The frictional force is acting F2. The weight is there W2. Here it is acting perpendicular to the ground as shown in figure. Now the tension is there. It is again acting toward the right side. There. Okay, these are the forces are acting on a body now. These forces, the unknown forces, what is the given now? What is the required now? What is the force that is minimum force that is required? That can be obtained by applying equilibrium equations for the body 1 and 2 separately and eliminate the common factor T, which is shown in figure. And with the remaining equations, we can determine the value of P now, which is now is explained below. Now, when I am writing the equilibrium equations for the body W1, since the forces are concurrent, only two equations are applicable, sigma fx is equal to 0, sigma fi is equal to 0. When the resolving the forces perpendicular plane, T is the positive, 4 directions, minus W1 sine alpha downward directions. Frictional force F1 downward direction. It should be equal to 0 now. That means T is equal to W1 sine alpha plus F1. Assume this is the equation number 1 now. But we got F1 is equal to mu N1. Already we got it mu N1 is equal to W1 cos alpha. So substituting this equation number 1 into, we got T is equal to W1 sin alpha plus F1 is equal to mu 1 W1 cos alpha. This is the equation number 3. We got the relationship between the T as well as the coefficient of friction and weight of the body and angle of inclination. Similarly, when we are considering for the second body of W1, W2, which is equal to 100 newtons, the normal reaction is acting upward directions, W2 is acting downward directions. The frictional force is acting toward the left side, that is F2. The tension is acting toward the left side, and the P force is there. Here it is making inclination. This force can be resolved into two components, vertical and horizontal components. This vertical component is equal to P sin theta, horizontal component is equal to P cos theta. Now, since in these problems W1 is given, alpha is also given, hence we can obtain T is equal to some numerical values having units newtons. We got the values. For the second case, for body W2, when we are resolving the forces perpendicular to the plane, N2 is acting upward direction positive, N2 positive, P sin theta positive, minus W2 negative, it should be equal to 0. Or N2 is equal to, we can take it as W2 minus P sin theta. Again, sigma fx is equal to, that is the forces which are acting along the x directions, minus T toward the left side, frictional force toward the left side negative. It should be balanced with the right side force P cos theta. So from these relations we got it should be equal to 0. From these relations we got T is equal to P cos theta minus F2. By using these equations, since the T value is already determined and two unknown forces are there, unknown quantities, theta as well as the P, by using equation number 4 and 5, we can determine the values of minimum force that is required to slide the systems, that is system of forces W1, W2, which are connected together and tends to slide toward the right side, we can determine.
Like, share, and subscribe. Hit the bell icon for more updates.